mg normal friction. So I'm going to use my direction of motion, my perpendicular. The direction of motion, I have mg sine theta minus friction, that equals ma. This direction, I have normal minus mg cosine theta equals 0, but I won't even need that. Sum of torques equals I alpha. The only torque present is created by friction, and it's created at a distance r. So Fr equals 2/5 mr squared. Alpha is A over r. So that one of those r's cancel out. This r cancels with this r. So friction equals 2/5 ma. So mg sine 30 minus 2/5 ma equals ma. Letter M doesn't matter, as it shouldn't. So move the 2/5 over here. That gives you 7/5 A equals G over 2, because the sine of 30 is 2. Oh, I
Sine
made screw.
of 30 is 1/2.
Huh?
Isn't sine of 30 1/2?
Right. So that would be 2
Oh,
over
okay,
2.
right.
So A is 9.81 divided by 2 times 5/7. So acceleration is 5g over 14, or 3.50. See, it's not that bad. Friction.
Wait, so is the capital R next to the F, like, of friction, is that radius? Or like, would be radius?
Yeah. So the torque by mg is 0. The torque by the normal force is 0. The torque by the frictional force is friction times r times sine of 90.
Wait, how do you know there's friction then? Doesn't a ball like have to like have friction?
Yeah, nothing can roll without friction.
Oh, so you have to like solve for friction?
Yeah, it's 2/5 ma.
Okay.
Yeah.
How do you know mg and mr is 0 for torque?
This here.
Center of
is
mass.
the mg r, and the r value is 0. This here would be normal r sine of 0, and that's 0. mg has no lever arm. The normal force does have a lever arm, but it's parallel to the force itself. Friction perpendicular to the lever arm, so that's why I can just get away with calling it FR. So that gives you the acceleration. From there, it turns into this is linear motion, this is projectile motion. Linear motion component, you have a triangle 4 at 30 degrees, which makes us 8. So v squared equals v naught squared plus 2a delta x. V squared equals 2 times 3.5 times 8. V is 7.48. Here, you need to find the time first. So, changing y is v naught t, 1/2 at squared. This is 0. Negative 5 equals 1/2. Negative 9.81 t squared. Once you solve t, delta x is v times t, which will be 7.48 t that you found from there. So this is all linear motion. This is projectile motion.
Where'd you get 8?
For the,
Where'd you get 8 in the triangle? For numbers B. on the right hand side of the chart?
The
hypotenuse?
acceleration is 3.5.
No,
No,
the
8.
eight.
for the
Hypotenuse.
The last one's just projectile.
Where'd you get-
This has nothing to do with rotation.
So where'd you get 8?
Just speed
Trick.
acceleration.
Oh, oh.
Oh.
It's not given. Okay.
You can see or easy, it's just, it's just like that.
Sine of 30 equals 4 over hypotenuse.
confused.
So 4 divided by the sine of 30 is 8. This one here, this is your force diagram. So the pivot creates no torque at all. Your sum of torques equals 0 because this does not rotate. The support in the back creates a counterclockwise torque, so force support times 0.5. These are all 90-degree forces, so the sines of 90 will be 1. Minus mg 0.75 minus little mg times 2. And that all has to equal 0. Once you go through this, what you'll find is the support force. Then the next piece is sum of forces is 0. So sum of forces equals 0. You have the pivot minus the support minus mg minus little mg. That all equals 0. The pivot has to cancel everything else out. This is what prevents it, the support on the diving board is what prevents it from rotating. The diving board's own mass and the mass of the person on it attempt to cause it to rotate clockwise. But it's a diving board, so it shouldn't move. Therefore, all of your forces have to sum up to 0. All of your torques have to sum up to 0.
Why is it 2 mg?
Hmm?
Why is it 2 mg and not?
This is the mass of the diving board itself. This is the mass of the person on the diving board. The diving board's mass acts at the center of gravity, which is in the geometric center. So that's just the sum of forces and sum of torques equals 0. A static equilibrium problem. This one here starts that way. There's only 2 things applying torque if this is the pivot for the door. So, I guess I should have made it more clear that the door's gonna rotate this way. So we have 3 forces, 1, 2, 3. This is a tension, this is an mg, and this is the force from the pivot itself. Pivotal forces don't create any torque, they're acting at the hinge, so it has no lever arm. These 2 torques have to cancel each other out, so the sum of torques is 0. That means tension R sine 30 minus mg half of R equals 0. This has got to be 30 degrees because this is 60. Doing this will solve the tension. Once we cut the rope, the tension's gone, so nobody cares about that anymore. In that case, you only have 1 torque present. Sum of torques equals I alpha. That's mg R over 2 equals 1/3 m R squared alpha. This is actually incorrect. This is 3. You want to do that. The angular acceleration integrates from 9.81 to 0. So dismiss 3. I realize I made a pretty gross negligent error. Does that help at all?
No.
It's just the same stuff. Everything's just spinning now.
No big deal.
Yeah. It's just spinning.
Wait, what'd you get for time for C?
The time I think came out to be like 1.01 seconds.
Okay, because like I got 1. So like when 7.48 times 1 just equals 7.48.
Watch how you round. But yeah,
Okay.
it's because it's 5 meters, and 5 meters takes approximately 1 second to fall.
Okay.
Yeah.
Wait, so for one, this is still the first one. For B and C, that's all just kinematics and
Yeah.
you don't have to take into account any like rotation.
Rotation.
No, although you could solve B by rotation if you
Right.
wanted. You could use energy.
Right, you could do MGH plus rotation,
Yep.
kinetic
Yes.
rotational, and
Yeah.
kinetic translational plus MGH.
And it'll be MGH equals
It's fine.
But
rotation.
there's still, isn't there still like MGH, is it still like high?
Yeah, but I don't really care about that last 5 meters.
Oh, okay.
So I would just do MGH equals 1/2 MD squared plus 1/2 I omega squared. So,
Oh my god.
yeah.
The test tomorrow, tomorrow. Are we just seeing 2 free responses?
I'm not
Or
sure yet.
You don't know?
No. I have the multiple choice on, that's all I got. Yep.
Could you explain the sum of torques in problem 1?
Yeah, there's only one torque present, and that's from friction. It acts at the lever arm, full length of it. So, the torque is just FR.
Oh,
Yeah, gravity doesn't apply torque because it acts at center of mass, and normal force doesn't apply torque because it acts parallel to the lever arm. Yeah.
So when you say like you don't know about the free response, could there be like 1 free response? Is that what you're saying, or what? Because
It'll be
he's
more than one.
okay.
Yeah.
Because he's like
Not getting that lucky. Yeah.
So is torque always an opposing force?
No,
No?
torque is any force that causes rotation.
So why wouldn't, in the diving board, why wouldn't there be any torque? Because isn't it trying to
Well, there's
rotate?
3 things applying torque, but it's in equilibrium, so they all cancel each other out.
Is that all to the right of the pivot point?
No,
If,
pivot's right here.
right.
So this one creates a counterclockwise torque. These 2 create clockwise torques. So this torque has to cancel out these 2 torques.
Okay, okay, that's why, okay. So it's just a matter of applying logic.
Sum of torques is 0. Yeah. Let's see.
It's the
25.
opposing force
in the dive.
in the dive, yeah. It's what's preventing it from turning. So, because at the,
this way.
yeah,
Yeah,
because
except
at the-
there will be
but,
0
like,
calculus
imagine it's a
involved.
counterweight, because if there's no counterweight on it, then when you jump, it becomes a pivot.
The sound forks section
Isn't
are
our everything's in
is
The pivot point's just where everything's at.
Torque is,
Find the force,
I get that the only force present.
yeah,
because there it
force
is. Find
times
the force,
lever arm
pivot
times sine
exerts on the
theta.
diving.
So the force being applied is friction. The lever arm is the full radius, and the sine is 90 degrees.
Oh, it's just the only force present was friction.
The only force that creates
Right.
torque is friction.
So
But-
that's why you found friction using the
But it needs
torque thing.
Yep.
That's beta for torque with normal force. Where's the 0?
So see the normal force vector right here?
Yeah.
Okay. The lever arm is a line drawn from the axis of rotation to the point of contact. So this is the lever arm.
Oh, that makes sense.
It is the shortest line possible from the axis to the point of contact. So that's why the lever arm for gravity doesn't exist, because gravity acts directly on the axis. Yeah.
So in terms of the diving board, what exactly is F of S?
a support force for it's really the force on, if you look at a diving board, there's two bars that attach to the ground. One functions as a pivot, the other prevents the board from itself just flipping over. So it's a supporting force pulling the back end of the board down to
So
stop it from rotating.
that's what you're solving for?
No, I'm solving for the pivot force.
So from FBS, how would you find the pivot force? Or would they be?
So once I know the supporting forces, the pivotal force is the only force that's acting upwards. So it has to cancel out all three of these downward forces. If you have an imbalance in forces, something is moving. So,
Okay, so you plug F. Okay, yeah, because you already know your energies. Okay, thank you.
yeah. Gonna be a fun day, isn't it?
Just absorbing all this information.
The rotation question on the C exam last year was actually horrible. Like, that question was actually impossible.
Which one was
It
that?
was like, I don't know, it was a spinning circle thing with a spring on it that had a block attached and it has this.
Oh,
It
yeah.
was actually toxic.
That one was brutal. That was barbaric.
I think I got a couple points on the, like, check the box, is it more than or less, you know, but like, other than that, like, it was bad.
I remember that. That was like, it was a disc that was motionless and had a spring with a block attached to the spring, and the spring was bolted in the middle of the disc. And the disc begins to accelerate. And as a consequence, the block moves farther and farther out, and you had to figure out like how far did the block move out.
Yeah, no, it was bad. And like, it was bad too. That's the third question. So the first question was like pretty easy, like carts moving down a hill or something, just like linear motion. I was like, okay, it's not too bad.
I remember that. The only trick on that one was people screwed up the fact that there's 4 tires on a car,
Right.
so your rotational energy is 4 tires, not 1.
Yeah, no, and then the next question was like not that bad either. It was like, I don't even remember, like some sort of amusement park situation or something. And then there was this, and so I was like, all right, this is going pretty well. And then I turned the page to the rotation, and I'm like, oh boy, all right.
Can you send
Now,
me that
as
video?
you're going through all this,
I'm gonna kill myself.
the one thing you don't forget to study is your circular acceleration, v squared over r. Because you don't want to be sitting in a problem that is designed to be very simple and turned out to be very difficult. Remember, we did talk about circular acceleration as v squared over r. Do not forget that.
What is circular acceleration?
It's the acceleration that allows you to essentially travel in a circle. Yep. In all fairness, I did warn you this is going to be a hard unit.
Well, hard is different from like impossible.
I
Yeah, it's not impossible.
I solved everything here except for that
one.
one.